Freightliner Corporation introduces the 1989 model Setback Axle 120 Conventional and the 1989 COE, available in both set forward and setback axle configurations. The new 120 and COEs are available with aerodynamic design advances that enhance both the appearance of the vehicles and the efficiency of their operation. For the 120 Conventional, a new sloped hood, aerodynamic bumper and fenders with molded-in headlights and turn signals contribute to this new aerodynamic emphasis. The 120 and new COEs feature new cab and chassis side fairings and extenders and newly designed rounded mirror heads. All these aerodynamic designs mean reduced wind resistance and improved fuel savings for all the 1989 model vehicles. We'll be highlighting the engineering advances that impact the service-related aspects of the vehicles. We'll examine changes in the frame design, suspensions, powertrain, and cab that require new service procedures. Some of the new aerodynamic components, however, like the headlight and turn signal assembly on the 120, also create new service procedures. We'll take a look at these components and assemblies from a service perspective. The 120 headlight and turn signal assembly, in fact, is a good place to start. The entire assembly mounts to the headlight bucket, which is built into the fender. The bezel, or trim ring, is mounted to the outside of the assembly. To change a light in either the turn signal or headlight, the bezel must be unscrewed from the headlight bucket. The turn signal light can be removed by simply unsnapping it from the bezel. Front turn signals on the COEs have been relocated from the mirrors to the front sides of the cab. New cab marker lights have been developed for the 120 and the COEs. The design features a MetroPack terminal which plugs into the cab harness for easy replacement. The new sloped hood for the Conventional allows adjustments for alignment of the hood to the cab at the two hood pivot hinges at the front of the hood, as in earlier model vehicles, and at the two newly designed rear hood mounting brackets and locators. Each of these four locations allow adjustments for fore and aft, side to side, and up and down alignment of the hood with the cowl. The Rockwell-designed hood is made of molded SMC, a fiberglass composite material significantly different than that used in the manufacture of earlier model hoods. The repair procedure for the new hoods, therefore, has also changed. There are many design and structural changes to the chassis and cab of both models. Although only some of these changes have created new service-related tasks, it's important that you understand how the vehicles have been put together. A new 10 1/16 inches high steel frame rail is now standard, for example, on the COE. There is a new overslung crossmember on the 120 frame, which adds lateral stability to the chassis. It's attached to the front cab mount brackets, which in turn are bolted to the frame rails. All the alligator and C-channel crossmembers are web-mounted instead of flange-mounted to eliminate holes in the rail flanges. The web-mounted crossmember bolt pattern is designed so any bracketry on the frame, such as the rear suspension brackets, frame rail-mounted exhaust brackets, and fuel tank brackets, share the same bolts. Fewer holes in the frame rail and more rigid mounting for all components result from this design, which improves the structural integrity of the frame. An alligator crossmember is located under the rear cab mount of the 120. Additional alligator crossmembers can be located behind the cab dependent on the wheelbase length. COE models feature at least one alligator crossmember located behind the cab, with additional ones possible also dependent on the wheelbase length. The web-mounted C-channel crossmember at the suspension center line and an inverted C-channel crossmember at the end of the frame complete the structures of both vehicles. The alligator and C-channel crossmembers come in one width only. For the different sized frame rails, various sized shims are used between the rail and the alligator crossmembers, and different sized gussets are used on the suspension and rear C-channel crossmembers. The number of shims and the size gussets used depend on the thickness of the frame rails. Bolts with hardened washers are also used as the standard for all structural frame fasteners. Rubber isolator mounting is standard for the rear of the cab, with an optional air ride suspension. The adjustment procedure for the air ride system is similar to that for adjustment of the air ride rear axle suspension system. The 1989 model vehicles feature an enlarged windshield design. A single rubber seal holds the two pieces of glass. To replace a single piece of glass, the seal must first be pried away from the metal flange of the windshield opening with a plastic paddle, then pulled away from the glass, which is then slid out of the windshield opening. A new piece of glass is slid into place. The seal is stretched back around the glass and then pried over the metal flange with the plastic paddle. If the seal gets damaged during the replacement process, the entire assembly must be removed and a new seal put on, and both glass sections and the seal must be installed as a complete unit. A single air-powered windshield wiper motor operates both wiper arms on the new conventional. Mounted on the left firewall under the cowl, the new motor can be reached by tilting the hood. There are no replacement parts for the motor, and motor lubrication is needed only on off-road trucks. No adjustments are required for the passenger wiper arm, bracket, and linkage, located on the right firewall. COEs still feature two air-powered windshield wiper motors. The left motor is mounted on the left nose skin under the dash. The right motor has been relocated to behind the center nose skin and can be easily reached from the tunnel after removing the grill. Freightliner's new soft ride taper leaf springs are standard on the front suspensions of the '89 model vehicles. The spring rate has been reduced, offering more deflection for the same amount of load. New shocks are required because the lower rate allows additional travel in the springs. Monroe shocks are standard on both vehicles. Brackets for the new shocks set the shock closer into the rail than on earlier models. This reduces stress in the frame rail. Note that the upper shock absorber bracket's pivot pin is positioned at the top of the bracket on the conventional and the axle back COE, and that the same bracket is turned over so that the pin is at the bottom of the bracket on axle forward COEs only. The Freightliner 112 has served as the model for creation of new rear axle spring installations. The locations and angles of the brackets are the same as on the 112, and all the brackets are web mounted. However, all the new suspension brackets are aluminum, and as mentioned, share bolts and bolt holes with the cross members. The radius rod and axle brackets are also adopted from 112 designs. A bar pin is used on both ends of the rod for the '89 model vehicles. The pin goes through the radius rod and two bolts pass through the pin into the casting. The setback axle COE comes standard with automatic brake proportioning for improved stopping distances while driving bobtail. An inversion signal valve and a proportioning control valve are the main components of the system, which is optional with all other vehicles. COEs equipped with ABS anti-lock braking systems on the tractor do not require automatic brake proportioning when driving bobtail. All '89 model COE and 120 conventional radiators are either single-pass vertical or single-pass cross-flow designs. The two-pass low-flow radiator has been replaced by a single-pass low-flow radiator. Vertical flow radiators with a top and bottom tank are used in COEs. Cross-flow radiators with side tanks are used in 120 conventionals for a lower hood slope. Some radiator parts are interchangeable between the 112 and 120 conventional. The radiator fan height for all engines has been lowered because of the new sloped hood design. A swing mount fan hub replaces the vertical adjustment type fan hub. On the conventional, there are three strut rods at the top of the radiator that extend back to the cab, one diagonally, two fore and aft. This design is also similar to that found in the 112. The engine air intake system is significantly different on the 1989 model conventional. The frontal air inlet is replaced by a new cowl top inlet system with a firewall-mounted air cleaner. Access to the engine is improved because there are fewer inlet tubes. A Donaldson air cleaner is standard on the '89 model vehicle. It's mounted on the firewall of the conventional, but is still engine-mounted on the COE. The element only is replaced with the Donaldson air cleaner. Suspended clutch and brake pedal designs have been developed for the conventional, which feature fewer parts and a simpler adjustment procedure than the floor-mounted designs that preceded them. The COEs feature the suspended clutch only, with a telescoping rod. There is no latching mechanism on the rod, similar to the design of the throttle rod on earlier COEs. The clutch adjustment procedure is simpler with this new linkage system. An over-center spring, which helps the driver disengage the clutch when the pedal is pushed about halfway, is a 112 design that requires no field adjustments. On the 120, the clutch micro switch has been relocated to inside the cab, just off the steering column bracket. The COE microswitch has been relocated to just inside the tunnel. The new easy-to-service heater-AC combo is mounted in the cab under the dash skirt on the passenger side. Access is excellent for all the unit's components, including the heater core, AC evaporator coil, blower motor, resistor block, thermostatic switch, expansion valve, and water regulator valve. The new unit features a single long-life blower motor that pulls 21 amps. It's rated at about 10,000 hours and is protected from overheating by a resistor block mounted on the blower housing. The conventional fresh air ducting has been relocated to the right-hand side of the cowl top to make room for the air cleaner. 2 vent holes on top of the cowl on the passenger side allow air to enter a plenum. A catch basin at the bottom of the plenum captures moisture, which drains out through an evacuator valve. The air moves from the plenum directly through the cab nose skin to the blower housing. The fresh air inlet on the COE has been relocated to just above the oil check door on the passenger side at the front of the cab. A plenum, catch basin, and evacuator valve under the cab deck operate similar to the system in the conventional. The heater AC system has a completely new control system, too. There are many electrical changes in both the 1989 Model 120 conventional and the COEs. Included as standard is the Vigil 1 warning system light bar used in the 112 conventional. This second-generation design features 14 LEDs, built-in turn signal timing circuit, and a single micro-pack plug-in connector. An optional second-generation Vigil 2 system includes all the Vigil 1 features plus engine shutdown features. The ignition-controlled circuit breakers have been moved to a 4-position ignition control breaker area. This provides more space for optional circuit breakers and more ignition-controlled options. A fuel shutoff solenoid valve and flasher relay have also been added. There's also a new junction block for the 7-way cable. The single blower motor for the heater AC runs on a single 30-amp circuit breaker. The blower motor switch has been changed to a 4-speed design. A new high-speed relay has also been added. The entry points for the engine and chassis harnesses into the cab of the 120 have changed. Plug-in connectors are mounted at the lower center portion of the firewall, with an additional set of auxiliary connectors in the same location. And the ignition switch start button has been relocated outboard on the left-hand switch panel. This program has offered only a brief preview of the major changes to the 1989 Model 120 conventional and the 1989 Model COEs. Detailed information regarding all these changes and the service procedures that result from them is available in the new Freightliner COE and 120 conventional service manual models FLA and FLD, and in the new Freightliner maintenance manual COE and 120 conventional models FLA and FLD. Our goal is to make all information about service-related changes to the vehicles as accessible and understandable as possible. To accomplish that goal, Freightliner's Service Training Department, which enjoys the reputation of offering some of the trucking industry's most comprehensive service training programs, has extensively updated its existing training programs. For information about the courses offered, the availability of classes and class schedules, please contact your Freightliner District Service Manager or call or write to the Service Training Department in Portland, Oregon. At Freightliner Corporation, we believe that every customer can be provided efficient, effective, and uniform service. Excellent service builds lasting customer relationships. We're dedicated to providing you with the resources you need to meet those customer demands. Because at Freightliner Corporation, we're dedicated to your success.